So before we begin, I just want to point out what we're going to use on the calculator. We are going to use the log key. Remember, the log key has a base of 10. You cannot change the base on these calculators. It's just base 10. We're going to use the natural log key, and then we're going to use base E. And all of those are located right here on this top part. Okay, so most of the time I will give you the equation in the problem. If it's population, or like bacteria, which is population, all of that kind of stuff I will give you. What I am not giving you the formula for is half-life. So if there's anything like at the bottom of your paper where it is talking about half-life, you are going to use this formula at the top. So remember, half-life is the amount left. I'll just write this I'm just going to write it conceptually. Half-life is the amount left, and it's equal to the beginning. I'm just going to abbreviate. Beginning amount is always raised to the 1/2, and it's always time over half-life time. That's the exponent. But we'll talk more about half-life in a minute. Let's go ahead and pop into number 1. The population P of a city is modeled by this exponential equation. Notice the base is E, the natural number. That letter T in the exponent, that represents time in years since 2000. According to this model, when will the population reach 150,000? So what do we want the P to be? They tell us right here. We want it to reach 150,000. So I'm going to plug in what I do know into the given equation and solve for what I don't know. I'm going to recopy this beginning amount, 105,300. And remember, that is E raised to the 0.015, and I'm looking for the T. All right, I am looking for the T. T is an exponent. T belongs to the base of E. I need to get E all by itself. I'm going to divide both sides by 105,300. When we divide by this, I'm going to use the calculator, and I'm going to get the exact fraction in simplified form because I might ask you for the exact amount. So turn your calculator on. Do 150,000 divided by 105,300. And of course, it's going to give it to us as a decimal. That's not going to work if I need free response answer. So you guys need to hit this second PRB. Remember, PRB converts it to a fraction. And I notice it's a mixed number. Remember, this calculator does impropers for us. After you get this, hit second, and then the button below PRB. And then when you hit enter, it'll give it to us as an improper fraction, which is exactly what we want. So when we divide both sides by 105,300, we get 500 over 351 equals E to the 0.015 T. Now, y'all, there is no way that I could write this as the same base. If I could write it the same base, it would be a super easy problem. But I can't. I can't make this turn into the letter E. So from this step, you log it. And remember, it's an E, so you have to use ln. So let's convert this to logarithmic form. So ln of 500 over 351. Remember, all logs equal exponents. And the exponent was 0.015 t. But remember, they're asking us when it will reach this amount, so I need t all by itself. So I'm going to divide both sides of the equation by 0.015. So the natural log of 500 over 300, or 500 over 351 divided by that whole thing is divided by 0.015 equals t. And y'all, I'm just going to put a bubble around that just in case it says exact form on the quiz. Maybe it will. I don't know. But we are going to find it because I might ask for the year. And if I ask for the year, you have to use the calculator. So here we go. Do not forget parentheses are your best friend. A lot of kids were getting wrong answers today because they were not using parentheses. When in doubt, just put parentheses around it. I'm going to type in the numerator. ln is over here on the left. Natural log of 500 divided by 351. I'm just going to close parentheses to be on the safe side. Probably doesn't matter, but better safe than sorry. So there's your numerator, but don't forget it's being divided by 0.015. So hit divide, and then type in 0.015. And there you go. Your t-value is 23.588, and that's rounded. Remember, T stands for time in years since 2000. So, according to this model, when will the population reach 150,000 people? I'm assuming it's people. That's going to occur in the year 2023. Or that occurred in the year 2023.